Hey guys, welcome to another video. Today's learning objective is all about algebraic notation and algebraic manipulation. So before we kind of get into it, as usual, feel free to skip to any part of the video if you think you know perhaps what's going on, just want to skip to a work example. Timestamps are here as usual. Okay, so let's talk a bit about what the learning objective is. And kind of before we even do that, some of the prerequisite knowledge we need. It's really important you check out the Intro to Algebra video that we just did, lesson 18. As it kind of covers what we really do need to know in this video. So learning objective is all about algebraic notation and algebraic manipulation. So there's quite a few of these here, and I'll talk through each of them in turn. But before we do that, let's kind of just remind ourselves what algebra is. Algebra is all about when we have kind of these unknown variables that occur in equations, for example. So say last time we used the example of the waiting time for a bus being 10 plus t. But a lot of the time in algebra, we don't see a t, we see, say, for example, x. We use, say, for example, 10 plus x. That's an x kind of, sometimes when you do algebra, you have an x kind of like a curly one like this, or kind of like that, instead of an x like that. And that's kind of just notation. And the reason we have an x like this is actually so we can differentiate it from the multiplication sign. See, this one here looks a lot like the multiplication sign, whereas this one looks a bit less than the multiplication sign. And in algebra, because we use this x so often, we actually kind of tend not to use the multiplication sign as much. So this kind of takes us to our first kind of learning objective. AB is the same as A times B. And say if we had, for example, the situation of x, if it was A times x, you can see how that looks pretty confusing, right? Is this x an algebraic x, or is it times multiplication x? So what we do instead is we just simply ignore this multiplication sign, and we can write it as ax, for example, or in this case, ab. Or we might actually write it some other way. For example, we can write it as, let me change my pen to show it different. We can do, for example, a dot b, and then I think I mentioned this in a video a while back, but the dot is kind of higher up here. It's not a dot b, kind of like a decimal point, but it's higher up, showing that it's a multiplication. Or we can do, for example, a bracket b, and these are all just different ways of saying the same thing. But the most common one you'll see is ab like this, just meaning it's a times b. And that's just something, as I said, we have this mathematical notation, just something that math has adopted over time. Okay, so the second one is 3y in the place of y plus y, and 3 times y. Well, okay, let's talk a bit about that. I'll just underline it here. Okay, so we know y plus y is the same thing as 3 times y, right? But then we know we don't in algebra, we tend not to use the multiplication sign as much, so we just write 3 next to y. And so this rule about a, b kind of just being next to each other doesn't just apply to different variables, i.e. what a and b is, but can actually apply to these numbers as well. Okay, another rule we have is a squared in the place of a times a, or a cubed in the place of that, etc. So, if you remember our kind of rules about powers, for example, we know, for example, 2 squared is 2 times 2. Well, by the same logic, a squared is a times a. And again, in algebra, remember, we don't use, the times sign that often, then we can write that as, for example, aa. That just kind of looks a bit ugly, and kind of, it takes up more space than it needs to. And since we've got this great notation of squares and powers over here, we can just write this as a squared. And likewise, say if we had, y times y times y, well, we could just write that as y cubed. So for example, let me just give you another one anyways. Say we had x, oh that's a bad, x times x times x times x. How would you write this? Just take a minute to pause the video and think about what that might be. Well, now there are 4 x's here, right? So that would just be x to the power of 4, and that's it. It's just kind of this notation. Okay, a over b in place of a divided by b. Okay, well, this notation is saying, for example, instead of saying a divided by b, we write this as a over b, which is a very fraction looking, right? And remember, that's all a fraction is. The fraction just means the top number divided by the bottom number. So kind of, I think, we've seen this kind of movement from this into this before. But this time around, we've just got these variables. We don't know what this number represents. This number could be anything for all we know. But we can still write this as this, kind of on the left to the right. We can still do that. Okay. Coefficients written as fractions rather than decimals. Okay, well, say we had something like, remember how we had 3y back here? Where is it gone? We had 3y, right? Well, say we had, for example, 3.5y, for example. Well, instead of writing this as a decimal, we can write 3.5 as 7 over 2, right? Because 7 divided by 2 is 3.5. So we can write 7 over 2 times by y. And remember, we don't really use the multiplication sign in algebra. So you get 7 over 2y. So that's all that learning objective is, saying that we can write decimals as fractions. And the word coefficient just means the number in front of the y. The number y is times by. So kind of as a quick question, say we had the kind of thing 8x. Sorry, that's a bad looking 8. What's the coefficient here? Take a minute to kind of think about this. Well, the coefficient here is just 8. So because we're timesing x by 8, that just makes 8 the coefficient. That's all that the word coefficient means. And then brackets. So again, as I mentioned back here, we can use brackets instead of the multiplication sign. So if we had something like, say, getting back to our trusty black pen. I know I've kind of been a bit all over the place with the colors today, but so say we had something like a say into b plus c. Well, this is just saying a times b plus c. So that's all brackets is, kind of just another way of writing the multiplication sign. And all of this mathematical notation, you might think, kind of, what's the reason we had this? Why can't we just stick to the normal rules we have? Well, it's the same reason, for example, you write y plus y plus y as 3 times y. It's cleaner, it's easier to read, and just means you make less mistakes. Think about if you have to write 5y and you have to write it as, what 5, y plus y plus y plus y, the 5 times round. You might copy it down wrong and make a mistake or something. So this just makes kind of our lives easier, and it's just there for that very purpose. So let's try a few examples to see if we kind of see what's going on. The example is deciding not to load. Just give me a second. Okay, the example has the example's decided to load. So it's asking us to simplify the expression 8f cubed k cubed n cubed times 7f k squared n. Okay. So remember, say, let's kind of break this down actually. Oh, sorry, the pen just decides to keep showing up. Okay, so let's break this down. So it's this first thing here means a times by f cubed times by k cubed times by n to the 4 times by 7 times f times k squared times by n. And let's just kind of have the same thing, like collect the like terms. We'll talk a bit more about that in another video, but say, for example, we can do 8 times 7 times by f times f cubed times f squared. Sorry, f cubed times f. So f cubed times f cubed times f, and then k cubed times k squared, and then n to the 4 times n. Well, that comes out to 8 times 5 is 56, and then f cubed times f. Okay, well, if we go back to our laws of indices, we know this is f to the 3 plus 1, or kind of, if we want to think about this, f cubed is the same thing as saying f times f times f times f, so i.e. f times f times f, and then times by f again. Well, that will just be f to the 4, right? So we can just write that as 56 f to the 4. So kind of, sorry, that should actually be a bit closer together, so let me rub that out. So 56 f to the 4, and then we can use the same logic here, laws of indices, k to the 3 times k to the 2, so we can do 3 and plus 2, so that just becomes k to the 5, and then we're doing n to the 4 plus times by n, which is just n to the 5, and there's our answer. Kind of a mistake I made as I was doing is I forgot this equal sign. You can see me adding this later. It's really important to keep that in because we're saying this thing here equals to this, which equals to this, which equals to this. And this is kind of the simplest way we can express it, right? There's nothing else we can do. We can't, multiply anything else together to make it easier and make it look nicer, I guess. So we've done what the question's asked us to. It's asked us to simplify the expression, and this is the simplest way we can write it. Okay, let's try another one. Simplify the expression this. So remember, what we need to do is kind of make it in a compact form. Get rid of all the multiplication signs and use power notation. So why don't you give the video a pause and see if you can give a question a go on your own. Okay, so in this case we've got 2. So first thing actually, when you see a question like this, what might be worthwhile is if you kind of look at the things that are in common, kind of that are alike. So you can multiply 2 by 3, right? But if you do 2 times c, you can't really simplify that further because you don't know what c equals. So you just keep that as 2c. But you know what 2 times 2 is, so that you can simplify that. 2 times 2 is 4, and then 4 times 3 is 12. So we can write 12. And same logic, we know c times c squared is c cubed, so we can simplify that. But we don't know, for example, c times h squared is. We just know that's ch squared. So we've done that, and then we've done the c's, we're on to r, so r times r is r squared. And now we've got h squared, so h squared times h, which is h cubed. And I think we're done. So let me just go back and actually underline everything to show we're done. So r, we've done the 2 r's, 2 h's, and then we've done the c's as well. And that's it. So when you see questions like these, you have to think about what you can do to make it more compact and more simple. But since you know, for example, what 2 times 2 times 3 is, you can simplify it. But you don't know, since you don't know what c is, you don't know what CR is. You can't simplify that any further than there is without knowing what CR is. So that's how it's as simple as it can get, for example. So you can't do, for example, c cubed times r squared because you don't know what either are. So hope that made sense. Kind of today we covered a bit on algebraic notation. It was a bit of a longer video. There's a few different rules, and it takes a while to get used to these rules. But if you do enough questions, they'll become second nature. So kind of really important to just practice some of these simplify the expression questions. Go away and practice those, and I'll see you guys in the next video. Thanks.